Okay, now let's find the x-intercepts of the graph of y is equal to 2x squared minus 9x minus 5 using the factorization method we just talked about. Okay, so we notice this is, again, a non-monic quadratic trinomial because the coefficient of x squared is not equal to 1, and we have 3 terms. It's not always possible to factorize these quadratics this way, as we'll see in the future. Sometimes we have to resort to using the quadratic formula or completing the square if we choose. But in this case, let's try it out. So remember that step 1 was to find two numbers whose product is AC. So coefficient of x squared is 2, and the constant coefficient is minus 5. So AC is minus 10, and so these two numbers must have a sum of V, which is equal to minus 9. Okay, so which two numbers have a product of minus 10 and a sum of minus 9? Well, minus 10 and positive 1 have that property. Okay, just let's check that mentally. And now moving on, we can now express minus 9x as a sum using these two numbers as the coefficients of x. So x will just represent as, 1x will just represent as x. Okay, so step 3 was to rewrite our equation using this new expression, right? Minus 10x plus x. And finally, we factorize by grouping. Okay, highest common factor of 2x squared and minus 10x is 2x. So in the brackets, we have 2x times x is equal to 2x squared, and then 2x times minus 5 gives us minus 10x, okay? X and minus 5 don't have any common factors, so we just leave x minus 5 as is, and we notice that this is already in the same form as this x minus 5 that we just wrote down. So once again, this has an implied 1 in front of it. So factorizing out x minus 5, as it is now a common factor, we are left with 2x plus 1. Okay, so we've written our quadratic equation in this form. And since we're asked to find x-intercepts, our goal is to solve the equation y is equal to 0. Okay, so applying null factor, our first solution is x is equal to 5. Our second solution is x plus 1 is equal to 0. Subtracting 1 from both sides, 2x is minus 1. Dividing both sides by 2, we get x is equal to minus a half. Okay, so our x-intercepts are minus a half and 0, and 5 and 0. Let's use CAS to check that. And this matches our result. Remember that the goal of doing this is usually to be able to sketch a graph, right? Because the important features of a graph are y-intercept, x-intercepts, if any. And since we're graphing, or we're learning about quadratic equations, usually there's a turning point involved, and we'll discuss that later on. Okay, next example. Express this quadratic equation in factorized form. Factorized form, we already know, just means we want to write it as a product of linear factors, right? This makes it easy to identify the x-intercepts. So let's factorize this using the technique that we've been practicing, because again, this is a non-monic quadratic trinomial. So let's identify two numbers whose product is AC. So in this case, 8 times 3 is 24. And these two numbers must have a sum of B, which is the coefficient of X, and that's 14 in this case. Okay, so everything's positive here, so it's fairly straightforward. We realize that 2 and 12 satisfy these criteria. Step 2. Okay, 14x is equal to 2x plus 12x. And step 3, we're just rewriting our equation using our new linear terms. Finally, we factorize by grouping. So highest common factor of 8x squared and 2x is 2x. 2x times 4x gives us 8x squared. 2x times 1 gives us 2x. Okay, and the second binomial, highest common factor of 12x and 3 is 3. And now 3 times 4x gives us 12x. 3 times 1 gives us 3. Okay, so as we wanted, we can now factorize out a common factor of 4x plus 1. And we're left with 2x plus 3 inside these second set of brackets. So there we go. We've expressed this function in factorized form. Let's verify that we did the right thing. Okay, remember we can go menu, algebra, factor, and let's factor 8x squared plus 14 times x plus 3. And there we go.